now in the shape of tiny little crystals mixed in with the soil, only in permanently shadowed zones in the north and the south poles. So that's closes up the story of the moon. And now I'll get you some idea, some little things that relate to the Arab fellows here in the audience. And one of them is the fact that during the Apollo mission 15, there were all kinds of changes to the spacecraft, including the addition of the rover, addition to scientific experiments in the command service module, all kinds of things. And we were talking to the astronauts. Everybody was concerned that all of these additions would cause some problems with the spacecraft, because every time you add something new, you may have something wrong with them. So we're kind of apprehensive about the fact that all of these new spacecraft will have something or other than. And so I told the astronauts we'll give them a piece of the first surah of the Quran, Al-Fatiha, as an additional protection. They loved it and they took it with them to the moon. And one of the astronauts of that same mission, Apollo 15, was Alfred Worden. I became friends a great deal, and he became interested in my background and my language and my history and all of that. And I began to teach him a little bit of Arabic, and he said, well, I'm going to give you teach me something I can say from the moon in Arabic. And I did, and this is the real recording from the mission where he said, Marhaban Ahl al-Ard, min Endeavor, ilaykum salam. So, hello people of the earth, from Endeavor, greetings. The other item that is a little more important is the fact that I am a member of the International Astronomical Union Commission that names things on the moon. And here is a map that shows the names of Arab scientists of the past that are commemorated on the lunar surface. This is just an illustration of the fact that our past was loaded with people who have contributed to humanity by talking about the space, by thinking about the heavens, by classifying things in heaven, by classifying time, by classifying things. And all of these great individuals are looked very highly up by their contribution to civilization in general. And their names are commemorated. The one thing that I would like to see happen is now that we have a younger generation of people in the room, that you too can become somebody who has added to civilization, added to that, by being a real scholar, by studying hard, by devoting yourself to knowledge, and by adding to human knowledge, so that one day you can become somebody who the world in total is honored by putting their names on a plate like that. Now we move into Mars, and Mars is a red planet. If you can look at the skies, and the only reddish thing that you see in the sky is the planet Mars. Everything else is quite bright white, except the planet Mars. And the reason for that is coming very soon. This is the way of the descent of the spacecraft in the atmosphere of Mars, and this is one of the illustrations of a jet propulsion laboratory instruments that landed on Mars, and the Spirit and Opportunity. And this is the way they shape it. It's this tiny little thing that moved on Mars to look at the surface and to photograph the pieces and move a little bit of a rock and see what is under the rock and the surface and so on. And they provided a great deal of information over the whole year. Now they get back to the color of Mars that has red color like that, and this is the only one, the only planet in the whole solar system that looks reddish like that, and the red color had perplexed everybody before. Why is it red? Why is it something that's different from all others like that? And it turned out that that redness is very much like the redness of the deserts of the North Africa and the Arabian Peninsula, meaning the Arab world. If you look at the Arab world from space, all of it looks red, reddish. And the reason for that is the fact that you have sand, and with the sand there is some iron oxides. And some of the sand grains themselves are coated with a very thin film of iron oxide, and that becomes the reason for the redness. And the features of the desert are very much like the features of planet Mars the way we see it today, which means that we can study Mars to understand the deserts of the Earth, or we can study the deserts of the Earth to understand the features of planet Mars. It's a wonderful synergy there. And for this reason, we concentrated on the study of the deserts in Egypt, and particularly the southwestern part of Egypt, because of the relationship between the two, because we found all kinds of things in southwest Egypt, which is actually the driest place on earth. In southwest Egypt, or the eastern part of the Sahara of North Africa, the received solar radiation is capable of evaporating 200 times the amount of rainfall. In the rest of the deserts of the world, including the Arabian Peninsula, that number varies between 50 and maybe 10. The driest place in North America is called Death Valley, and the aridity index of that, the Death Valley in California, and the aridity index of that is 7. And here the aridity index is 200, meaning just incredibly arid. In the western desert in Egypt, sometimes it does not rain at all, not even once, for 50 years. And this is very much like the conditions on Mars. Now, the reason when you look at this, you can say that if there is absolutely no water, the only agent that can change things is wind. That's why you can see the results of wind erosion greatly. This one here is called the Uwainat Mountain, Jabal Uwainat, at the border between Egypt, Libya, and Sudan. Exactly, the three countries. And you can see it's the dark brownish feature. It's surrounded by a spindle-shaped reddish material, and then there is fine sand on either side. Now this kind of feature we saw all over the place. There is one on the left side is Hajar al-Jarda in Libya, very much like a little hill that is surrounded by this spindle-shaped thing. And on Mars on the right, two craters that are surrounded by these two dark features in the south of them, or to the bottom of it. When we first saw the features on Mars on the right, with the two craters with these two things behind them, it was interpreted by geologists, by NASA, immediately as our two volcanoes. The material that came from the volcano came up, and that is dark material because most of the volcanic material on Mars and Earth is dark color. And then the wind actually moved it to the south. And that's why it is, and they wrote papers about that until we found this feature on the left in Libya, where we said it is not at all a volcanic feature, it's not at all. It must be a crater, meaning a prominence, something that sticks out of the ground. And the wind brought in the light-colored material on either side, and the area, the spindle-shaped area behind it on the bottom, is just a sand-free area that was protected. The prominence protected it from the wind, the passing wind. So it is not volcanic material. It is only a place where the deposits covered on either side, but left this area because of the wind came on either side. And that became a very important thing in other interpretations. And here we have features again on the left and southwest Egypt. On the right is Mars. These light and colored streaks, very similar topography. On the right, we see a feature that was taken by a Viking mission on Mars. And when we saw this mixture between very large pieces of rocks and middle-sized pieces and very small pieces, we thought that this must be the result of impact, because this is where you have a meteorite hit the surface and blast out the material, and therefore they will have a mixture between big pieces of rock and small pieces of rock and all kinds of variations in the size. But then in southwest Egypt, at the end of one of these river channels, we see this same kind of mixture. Very large pieces, middle-sized pieces, more pieces that could have been brought by water. So we again, it's not necessarily an impact, but it could have been a water deposit. And finally, this comparison also on the right side was a picture from the Viking Lander 2, where we saw rocks that have these pits in them. And on Earth, when we see this kind of thing, we see that as we interpret it as basalt that has little open vesicles in it, and we call it vesicular basalt, meaning basalt rock that has a little bit of empty spaces there. At the time of formation, this is how it matures. But on the left, we see some sandstone in on the southwest region that has pits, and these pits were not because it was volcanic rock, but the pits were created by wind drilling. I mean, the wind carries sand and hits the surface and it loops in it like this, and it actually nearly drills the surface to form this pitted appearance. Therefore, there is quite a bit of relationship between the deserts of the Earth and the deserts of Mars. And in the case of Mars, also we come back to the potential of water in the polar regions, because the polar regions are the coldest places where water vapor accumulates and becomes a form of ice and stays there for a while, like this in the North Polar region of Mars. And we can see the effect of some water falls on some of the crater sizes, as well as some actual honest-to-God ice deposits within craters on the surface of Mars. Meaning that, yes, indeed, there is a correlation between the potential of water on Mars that comes in once in a while, like the deserts in here we haven't, but the water here stays as water. On Mars, because it's a very cold planet, then it becomes ice. Therefore, these relationships become fascinating to us from the geological point of view. We can look at these different planetary bodies, we can compare them to each other, we can figure out the processes that acted upon them to form their features, and then we can correlate them and see what is identical, what is similar, and what is different, and why. What does that mean as far as the history of this planetary body? What does that mean as to the relationship between these planetary bodies and each other? And all of that helps us basically to have a reflection on the Earth and the history of the Earth, and in many ways, what is it that we should be looking at the Earth in terms of what the Earth is going to be in the future too. Thank you very much. I intentionally left some time for questions because I know there are all kinds of questions that are being roaming in the... Any questions? There are no questions, so I'll go ahead. Yes, go ahead. Yes.
Thank you, Dr. Almonzer. There's some questions.
Maybe after.
Question after the question.
After the question.
Okay, I hope the younger first you go ahead. We need to hear you. Say, stand up, say your name, and say your question.
Hello, my name is Ali Al-Asfour, and I would just like to say thank you for coming here today. It's a real pleasure to see you.
Thank you, sir.
And your presentation was wonderful. My question is...
This is my public press agent.
My question is, today, these craters that formed on Mars have relevance to geothermal activities on Earth. How could we use that to, how shall I put it, predict a certain effect that will happen here in a few years or 100 years?
Absolutely, and that's what I'm saying, that this relationship, because as I said, that the moon stopped evolving, and we can now look at the Earth's history, the way the Earth used to look like the moon way back then, and then Mars is still evolving now. The Earth is evolving more than Mars is evolving, and therefore we can actually relate these things together. And specifically as far as geothermal energy and so on, that actually depends on the local area, so I cannot generalize for its use in general, but we still believe that there are hot spots on Mars because there are volcanic build-ups. Actually, the largest volcano that we know in the solar system is Mount Olympus. It's the height of the volcano is 9 kilometers. That's that. So there are.
So in the future, we can say that we might be able to get energy from Mars. Might.
If we can get there, yes.
My name is Jan Fogelquist. Thank you. It was a very interesting lecture. So you had mentioned that the moon is not evolving any longer, that Earth continues to evolve. Is that because the moon doesn't have the volcanism of the Earth? I mean, that it's made just of the more superficial layers of the Earth? and cool down and just stopped evolving? I just wanted to be sure I understood.
Oh, very good. Actually, that's a little more involved than that. It is, it's due to the fact that how much of the very heavy elements are included in that planetary body. It's the easiest way of thinking about the Earth and the Moon, to have them being born at the same instant in time from the same chemical batch of elements but in different amounts, is the fact that they were all together, and actually the Moon was what split out from the Earth, and on the Earth there was much higher percentage of the very heavy elements, which include all of the radioactive elements. So the Moon had less of these, so the nuclear fuel in the material of the Moon was spent. But we now still, on Earth, we still have a lot of nuclear fuel way down there that's still cooking. يلا شبيبي يعني. ايوه عايزين الصغار دول هم كلهم يعني عشان انتوا المستقبل وانتوا اللي هتعملوا الرحلات الجديده الجايه.
السلام عليكم. Dr. Farouk, it's a pleasure to have you here in Saudi Arabia, and it's a personal pleasure to ask you this question. Actually, I took a course about astronomy in the university, and my term paper was about moon landing, and I was thinking, and I'm still really think that it's a fake thing.
يعني بعد كل اللي قلته لك ده نبغى يا
Regarding the rocks, 6 months ago, the BBC broadcasted something about a rock that was sent to a Dutch politician, and they discovered that it was claimed to be one of those rocks that they asked.
But they sent it to a politician, you said, yeah?
Yeah. And this is the same thing.
يعملها أي حاجة. يعملها كراميلا.
I believe the moon landing was a Cold War propaganda issue. And if you are saying that the rocks were coming from the moon, but isn't there a possibility that those rocks are just the meteorites rocks that came from outside into the
No, we do know what the meteorite compositions are, and we have a great list of the types of materials from meteorites, and we have samples from meteorites. We have samples from Mars as meteorites. We have samples as meteorites from all over within the solar system, and so we really know the difference between meteorites and rocks that were formed under the geologic conditions that formed the Earth and the Moon. Believe it happened. As I told you, there are samples. There are samples.
It's so difficult for me. Thank you.
Sure. But heck.
Assalamualaikum, Dr. Farouk.
Okay, sure. Go ahead. Go ahead.
So it was a pleasure to watch this presentation. My question is about your opinion on whether the moon has the moon cycle. Does it have an effect on Earth or not? Has your research or any research that you know of explain how the moon cycle has an effect on all living creatures on Earth?
Absolutely. I mean, there are two bodies very close to each other. Each one has gravitational pull, and the moon has the moon's rotation around the Earth has effects on, including the whole oceans, and the oceans change shape with the whole water on Earth change shape. There are all kinds of effects because of the gravitational pull between the Earth and the Moon. Absolutely.
The moon, as it goes through its cycles, the reason it changes its shape is because of the shadow of the Earth on it, right?
No, the part of it that's exposed to the sun, not the shadow of it. The part of the moon that's exposed to the sun that we see.
That's the one we see. Well, the question is, if the moon has a shadow, its effect shouldn't really affect, right? I mean, the gravitation of the moon should always be there, even though it's not lit up by the sun.
That's correct. Yeah, that's correct. The gravitational pull does not depend on the shape of the moon that we see.
So why is it that when there's a full moon, there's more pull on the water?
No, it is because wherever the moon is going over the water, you get that pull, the largest pull. It just happens because of the rotation that when you see it, you can see that. So it is not only when you see full moon, not at all.
Just one last question. Did you know anything about the magnetism of the moon and how it rotates around the Earth? Does it rotate around its own axis? Does it have magnetism?
Yes, it has its own, yes, and there is a magnetism on the moon. It's very weak magnetism, but there is one, and it has polarity that's quite dependent on the axis of the moon, yes, axis of rotation.
Thank you.
Sure. Yeah, go ahead. Yeah, go ahead.
That answers.
Go ahead. انت هقول اقول.
You said that.
Where is خد الميكروفون. قول اسمك ايه؟ الميكروفون. زعق كده عشان نسمعك وقول لنا عايز ايه.
السلام عليكم.
السلام ورحمة الله وبركاته.
فاروق.
نعم.
You said earlier that there was water on Mars and an atmosphere. Was there any life source in Mars?
That is an excellent question because we all know that life depends on water. And when you see water on some planet, then you immediately think, but was there water? And that question we asked ourselves the minute we saw water features on Mars. And to this day, we have absolutely no specific answer. In 1976, there was a mission that was dedicated to that. There was a little box that costed $50 million that was sent to Mars, and it will take some soil and mix it with water solution and heat it up, and then take that water and see what happens in there. If there was if something absorbed that water and something reactions happened, then this may be indicative of life activity. If there wasn't, there would be none. So there was activity, but there was absolutely no organic cells in it whatsoever. We had an analyzer to analyze organic activity, the cells and the cells. So there were absolutely no answer, because how could you have this biological activity and absolutely no organic remains? So that was a huge question mark since then. And to this day, we haven't answered that. So it's an excellent question. Maybe your generation will find it, because it is one of these very basic questions. If you have a planetary body that had an atmosphere then and a temporarily small atmosphere now, is that viable for life? And that life might be in any form, different from life the way different from us, physically, naturally, and different from any life that we talk about, not trees and things like that, might be something different. So is it or is it not? And that is one major question for humanity, and that will not be answered unless we continue our look into space and our exploration to answer that one question, because it is very significant. Are we alone? And why are we alone? Would God just put us on this earth and had not created things otherwise? God had said, وَخَلَقْنَا الْإِنسَ وَالْجِنَّ. So there were all kinds of potential for creation. So are we alone or are we not? And we do not have the answer to that. Your generation will.
Thank you, Mr.
Thank you very much.
Alaikum. Could you please talk to us a little bit about your experience with NASA in terms of scientific research and the environment for innovations and of developing motivation in people to go to science and research and have the energy and desire to elevate the desire? And if you could also please...
No, that's enough. This one here... I'm telling you that's enough, not to cut you off at all. I'm actually saying that's enough because that is a very basic, very significant question. We were just talking about it in the little room before we came in here. That's a very basic question. Number one, the Apollo program was more successful than anything before it and anything after it, because it was a very specific program. It has a very specific objective that everybody can understand, and that had to be finished within a specific period of time. It was said that we want to send a man to the moon, return him safely to the Earth within 10 years, something that everybody understood. That's it. The government said this, and here you go, this bunch of NASA, you go do it. And it's none of my business how to do it, but it's your job to do it. Now, how did they do it? It is all specifically by what you asked about. How to motivate people, how to make them innovate, how to make them pull together, how to make them create. And that was because of the way NASA managed things. Because the administrator that built NASA was, I was telling colleagues here right before the lecture, that he is the best manager I've ever seen in my life. And I've met all of the presidents and kings of the Arab world, many ministers throughout the place with all kinds of heads of governments galore, heads of companies and all kinds of things, but I've never seen really a manager that had that incredible quality. By being trying to be very personal and being the source of motivation. And I tell you how was he personal, how he motivated. How he was personal, because you asked about my history. After I joined NASA, about just 6 months later, I was promoted to be a supervisor. And they told us that with the supervisors, the administrator of NASA meets with all the supervisors. So the year I was promoted was 1967, end of it. I was told, called in with the rest of the people that were promoted, and there were 16 of us. And we entered the little room, government room, where the man is going to come and talk to us and leave. And we were sitting in 4 rows of 4 each chairs and sitting quietly and waiting for him to come. And he came in, and he started with the first person in the last row, and he would look at him, smiling, and say, "My name is Jim Webb." And he waits for him to tell him his name. And the next one, even though he just said his name, to tell the other guy, "My name is Jim Webb." So the other one would look in his eye and say, "My name is Jack something, and my name is Farouk al-Baz." This is one by one. Each man would look at him in the eye, and he introduced himself. And then he stood up in the front, and he said, "I came here to tell you guys that I am so honored to be working with you. Not for you to be working with me. No, I'm working with you. But now that you have been promoted to become supervisors, this is a great thing for you. And now from here now on, none of you is supposed to do any work." And we stopped. And we thought, "What do you mean?" Send us home. Because your job is to make sure that you are going to be able to get from the people that work with you beyond what they're capable. And the way you do it is like this. This is the way we think about it. If you, each one of you, is able to get from every man that works for you all what he thinks he is capable of doing, we shall surely fail. But if you're able to get from every man that works for you more than what they think they are capable of doing, then we'll make it to the moon. So, and you get out of this room and you walk to your work with these words filling your mind and juggling all the way around and around, because here you are now motivated to do the impossible. From every person that works with you. And they had 6 PhDs working with me. Now I have to think, how do I get each one of them work and produce more than what they think they're capable of doing? So I have to make it easier for them. I have to pave the roads for them. I have to encourage them. I have to push them. I have to do whatever it is. To do this or else we're not going to make it to the moon. And so each and every individual felt he is part of this thing, and we are going to make it, and God damn it, we're not going to let the Ruskies beat us, and we're going to do the move. So maybe we now say thank you.
Thank you, Dr. Almonzer. This was such a treat. I would like to introduce you to the Manager of Central Community Services Department, Mr. Musab Abayad.
Dr. Almonzer, thank you very much for a very enlightening and inspiring presentation. What really counts is not we as old people look at it, but it's the future generation. Again, as we hope you will be able to join us again. As a token, we would like to present.
Thank you. Thank you very much.